Okay, so hello everyone, and thank you for joining us. Today we'll be talking about how we built a production-ready chat SDK using Jetpack Compose. So let's get into it. So my name is Filip. I'm the lead Android developer for Jetpack Compose at Stream, which means that I kind of work on this SDK and maintain it, and I'll be doing it for a while. I'm also a GD for Kotlin and Android, and I'm a published author and conference speaker. If you want to reach out to me, you can do it through Twitter or LinkedIn. Those are kind of the two best places to go. And with that, I'll hand it over to Márton.
Hey, my name is Márton Braun. I work as an Android developer advocate at Stream, and I also, in this capacity, work on the Compose SDK a bit. The best place to find me is generally on Twitter, and you can also go to my website to check out all the written content and talks and stuff like that I'm doing. So let's jump into the actual contents though. So I want to give you a brief overview of what we're going to be covering in this talk. First, we're going to start with why Jetpack Compose, why Compose is exciting in general, and why it's exciting for us at Stream specifically. Then we're going to talk about using Compose in production a bit, because that's something that people have some doubts about still. And then we're going to take a look at some of the actual SDK and the code and what things we've done when implementing this SDK. So we're going to look at the design system that we came up with for the components that we ship. We're going to look at some common pitfalls and concerns around Compose. We're going to give you some tips on how to write readable Compose code so that you don't get lost in it. And finally, we're going to touch on how we've managed to provide customization in our Compose SDK. So first things first, why Jetpack Compose? Compose is a really hot topic right now, and it's safe to say that it will change Android development forever. A lot of people believe this in the community, and so does Google, as far as we know. So Compose promises to solve a lot of the problems that we had with the old UI toolkit that we're working with, which is based on views and XML layouts. Most importantly, perhaps, it offers faster and more efficient development. It, of course, has some learning curve because every new technology does, but it's relatively intuitive once you get some of the core concepts down. And after that, there are a lot of things that you can simply discover by writing Compose code and using things like auto-completion. Compose is a declarative UI toolkit, which is something that a lot of different UI toolkits on various platforms have been gravitating towards in recent years. This is a very common thing for modern UI toolkits. Apparently, it's a very good idea to describe UI as like a mapping of state to UI as a function. We also have components in Compose, which are defined as functions, which makes them really flexible. And these two things together give us really deep customization, which we're going to show you some examples of later on. And finally, something awesome about Compose is that it's all Kotlin. We just love Kotlin in general, of course, but it's also nice from a technical and theoretical perspective. We used to have the problem of writing layouts in XML and then having Java or Kotlin code that's the actual executable code in the application. And we were always trying to bridge this gap. We were inflating the layouts. We were somehow looking up the views that are in it. And we had to deal with a lot of problems there. And here we're just editing simple Kotlin code. Every declaration is in Kotlin. We have really good tooling there. We have auto-completion, as I mentioned already. We have navigation for Kotlin code that we're using day-to-day anyway. And yeah, things like finding where a component is used is just finding the usages of a function, which is something that Android Studio is really good at. Now, let me talk a bit about why Compose is really exciting for Stream. So at Stream, we build a chat API, a backend service that we sell, and we also build front-end clients for this and also backend clients. On the front end, we have clients for native Android and iOS in Kotlin and Swift respectively, but we also want to meet users where they are. So we also have support for cross-platform frameworks. So we also ship a separate React Native and Flutter SDK, and all of these provide really nice idiomatic APIs for the given platform. And we're doing the same kind of thing on the backend as well. For server-side clients, whether you're building Node.js or Spring or something in Go, or you're in the .NET world, wherever you are, we want to meet you there, and we're providing a dedicated server-side SDK for that. So we want to do the same in Compose because you could use our existing Android views with Compose's otherwise excellent interop features, but we don't want to force you to do that. We want to give you really nice and idiomatic and easy to use and convenient Compose components, which will just fit right into your application and that behave the way that you expect them to behave, so that you can easily provide state, you can easily customize them, and so on. And customization is actually one of the great things that Compose can give us for our SDK. This is one of the main focuses of our client-side SDKs. Our customers want to integrate our chat into their applications, but they also have a lot of customization requests. They want custom looks, they want custom behavior, and they want the chat to feel like a native thing in their application. And Compose can help us here greatly. Specifically, its support for theming and the slot APIs that it can provide us are something that are really trivial to do in Compose and super important for our customers. And these were very difficult and in some cases just impossible to be this flexible using the XML-based and view-based UI toolkit. Okay, so let's talk a bit about using Compose in production. And I'm going to be quite brief about this because there are a lot of people evaluating Compose and trying to figure out whether it's production ready. We know that it's 1.0, but some people felt like it was a bit rushed because like arbitrary deadlines and whatever. But in our experience, we had no trouble with Compose's stability, and that's pretty much the entire story. So we've been using Compose since the beta versions. We started development on the SDK back in May, and we built most of the SDK while Compose was still in a beta. We actually shipped its first release on the day after Compose 1.0 hit. So we worked through the betas with our Compose code, and we never had any stability or performance issues with Compose. Of course, while the core APIs are stable, you still might see some things that are experimental when you're building your Compose applications. You can mostly avoid these. This really is a small percentage, but you should be aware that there are some APIs that if you need some very specific features, then you're going to have to rely on some experimental things, which doesn't mean that they don't work, just means that they might change in the future. So you might need to put more effort into maintaining that code. Here are some APIs to watch out for. So there are the Accompanies libraries, which are first-party Compose libraries from Google, but they're not shipped as Jetpack libraries yet because they are experimental. As the README of that project says, these might be dropped in the future in favor of other solutions. They're really like still figuring out how to do certain things in Compose. And this is an example of that. Then in lazy APIs, we have some really awesome stable things. We have lazy columns and lazy rows, which are really convenient replacements for the view system's recycler views. But some things in the lazy APIs are still experimental. For example, if you want to use sticky headers in these components, then you're going to have to use some experimental APIs. And the same goes for using grids. Finally, there are some modifiers that are still experimental, mostly related to special click handling. And there are also some material components if you're building on that layer of Google's Compose libraries that have experimental overloads. Again, this is usually around clickability. So clickable cards and surfaces are something that are experimental there. To sum it up, we can pretty safely say that Compose is production ready and here to stay. And we've had and are still having a great time building Chat SDK on Compose. We managed to build this SDK to its first release in about 2 months, and it was pretty much just Filip here building that. While building the same thing using the traditional Android views took us roughly the same time, but about 3 or 4 developers. These projects are not quite comparable. There are a lot of factors that go into this, but to simplify it and summarize it, we estimate that we can move at least twice as fast when we're building these components in Compose compared to what we can do with the view-based system. With that out of the way, I'm going to let Filip actually show you the code that we've created.
Yeah, thank you, Márton. So now that we kind of reassured ourselves around Compose and we know that it's production ready, we know that we can build something with Compose because we already have that. Let's kind of dive into our component design system and see how we design our API and what you can apply to your own APIs when you start building them. Some advice that might help you build your entire API or SDK. So because we have a very specific use case in Chat SDKs, and that is that we want to have a very fine balance of default implementations and everything kind of working out of the box, as well as very complex and deep customization for our users, because our users do tend to want to, for components to match their design systems. We decided on these three levels or layers of components. First being the screen components. So screen components, as the name states, represent an entire screen. They're out-of-the-box solutions with limited customization, but they're really good because you can easily use them in just a few lines of code to prototype your solution, to test our API and see if your kind of MVP works with our application and if you want to go ahead and apply more customization or more manual work. For that, we have bound components, which are also out of the box solutions, but for a portion of the screen. So for example, if we have a screen where we have a list of messages, where we have an input field to send messages, then the list and the input field will be separate bound components. They are bound because they connect to our view models and set up all the operations for you. So you don't really have to set anything up yourself. So you don't have to set up initial data loading operations or operations to send the data. Everything is predefined for you, but at the same time, you can customize them through different types of actions or slot APIs, as Márton hinted before. And finally, the last layer are stateless components, which are very similar to bound components, except that they are not bound to a view model. They are state-driven with external state, which means that you can offer a very deep customization with it. You can customize where the data comes from, what state you want to show, which means that you can also customize the data handling operations yourself. You can also customize the action handler. So what happens when the user clicks on specific buttons or something like that. And finally, we have a very rich set of theming customization as well as slot API customization. So you can truly override these components with some default implementations as well. So taking a look at the screen component, we have the messages screen here. As you can see on the image on the right-hand side, this offers a rich set of features and a rich experience. So essentially with a few lines of code, you get to build an entire screen where you can chat with other people, send attachments, browse them, and so on and so forth. So you get an entire screen in just a few lines of code. In terms of its signature, as I mentioned, there are only a few parameters that you can use and pass in. So there's limited customization, but at the same time, you get a very rich experience with just a few lines of code. The only important parameter here is the channel ID, so that we know which channel to open so you can chat in. Next up, we have bound components. And with that messages screen, we can take a part of it through the message list. The message list component shows a list of messages, as the name states. You can still scroll through them, you can browse them, you can click on them. You also can have some actions such as selecting a message, scrolling to the bottom, and so on and so forth. So pagination and those things are included. Even though this is a small part of the screen or a very focused part of the screen, it still offers you a full rich experience with only a few lines of code that you can integrate with your own custom UI or the rest of our components. Its signature is a bit more complex. The only important parameter here, or the only required parameter, is the view model, so that it knows to which view model it should be bound and where it's going to get the data from. Once you pass that in, the rest is pretty much set up for you. You don't have to tweak anything unless you want some customization. And you can do that through the following actions as well. So we have different types of actions that you can override. And you can also intercept these events, which we'll talk about in a moment. Once you customize the actions and once you set up the data handling operations, you can also customize some of the slot APIs so that you override how the UI looks or what data is represented. So here we have the item content, which actually represents each item in the list. If you want to customize it, you can have the same component used here, which is the message list, and you can have these 4 different types of UI based on your customization. So you can have the default look, which is visible on the first screenshot. You can have a more colorful look if you're building that kind of an app. On the second screenshot, you can have a more simple, more basic UI on the third image, or you can have a more Slack-based or Slack clone application, as you see on the last image. So all of these images, all of these UI types are represented with a single component and just overriding a single item. And finally, we have stateless components. Again, going back to that message screen, one of the stateless components that we use is called messages. It represents the state when you have loaded messages and when you have something to show. So here on the right-hand side, you can see that representation, and you can see the signature of the messages. So again, messages is a stateless component, and that means that you have to provide the external state that's going to be rendered. In this case, this is the messages state, and you can also provide some of the actions that we support here, as well as the item content slot API, as we mentioned before. If you take a look at the messages state, it's just a simple data class with a bunch of properties that represent different types of state within the component, or also for some of the bound components that we use. So here at the top, we have 3 flags, which are used for loading and pagination. So in this case, the isLoading flag is used to show a basic loading spinner when there's no data in the messages screen, or you haven't loaded any messages yet, or actually you're loading the first set of messages. And then the second or the next 2 flags as isLoading more and end of messages represent the pagination flags. So if we are loading more messages and we haven't reached the end of messages, then we show a loading header. And this is how easy it is to build for us. You just have to represent or provide the required state. Then next we have message items, which are the actual messages in the list. So in case we have an empty list here, we will show an empty state. And in case we have loaded messages, then we show those messages. So in this example, if we have empty message items, we will just show an empty state that the user can see. And then once they start sending messages, you'll see the screen as we've shown before, which can be whatever type of message they've sent. And finally, we have some miscellaneous properties here that represent different types of state. So the selected message shows an overlay or represents an overlay. The current user and the parent message ID represent the thread mode that we're currently in, if we are in one. And then the new messages state, as well as the unread count, show or represent the unread message indicator. So let's take a look at how it looks. So if we have a selected message, we show an overlay, which is visible on the right-hand side. So we show some extra options for the message, such as leaving a reaction or replying to that message, starting a thread, editing it, or deleting it if we own it. And if we have new messages state, as well as the unread count, we can show a scroll to bottom button, as well as show an indicator of how many messages the user has in thread. The current user and the parent message ID represent the thread state, which we don't really show now on the screen because it's the same as a basic message list, except that we are currently in a thread. So that is how our components work, and that is how we design the API. Everything revolves around those 3 types of components that we use all around the SDK. So let's take a look at some of the common pitfalls that we've had, or some of the things that you might run into and you might want to avoid when you're designing your own APIs or when you're building applications using Compose. First and foremost, this is very, very common, and that is thinking too imperatively, especially if you're coming from the XML-based system. So because in Compose, everything is declarative, all components are functions, you can't really update the state in terms of UI, or you can't really set listeners by finding a view by ID and then setting whatever data you want on it. This is something that's completely different in Compose. So once you start thinking more, simply and thinking in terms of Compose, as Márton mentioned, just writing Compose code and learning it on the go, you'll be able to go over this pitfall and you'll be able to think more declaratively and more intuitively in terms of Compose. Next, you might want to think about customizing your components and when to avoid hard-coded customization. So if you're using modifiers in your components, which is a very common thing, you might want to avoid using too many of them or hard-coding them in your internal code. Because if you are exposing a modifier parameter or these components to your users, then they might want to set their own modifiers And because the order of the modifiers matters, you might override their own customization, such as a background color or something like that. So make sure that you avoid using hard-coded modifiers when possible. The next is pretty straightforward, which is trying to migrate everything. Similar to what happened with Kotlin when it became first class in Android. You shouldn't really move and migrate the entire application in one go or build an entire thing in Compose in one go. You should try building things slowly. And in Compose, we have this bottom-up approach where you start designing the smaller components first and then composing them together into larger components. So instead of trying to build a complex component in one go, try to think about the little details, little small things first, build them, and then combine everything together in a more cohesive and a more complex UI. And finally, there's a bit of a lack of examples. Even though Google has a ton of code labs and tutorials and documentation, obviously, and more content is being created on Compose, as you can see, there aren't too many examples that solve every single problem, obviously. And as you're building your own solutions and your applications, you might run into very specific issues that you just can't solve with the basic documentation. On top of that, there's a lack of best practices currently. Sure, there are some guidelines, which we'll talk about in a moment, but still there's just not a very large set of best practices out there. And in that case, what we kind of recommend is just playing around with Compose, seeing what works for you, what is working for your application, and exploring it on your own. Well, obviously talking to the community, because you might also be one of those people who sets the best practices with the community as you explore this crazy new world. Now that we've gone through some of the pitfalls, what were some of the concerns that we had while building this SDK? So some of the things that we were kind of worried about is how do we approach dynamic size or dynamic items when we have components that are combined together? So for example, we have an avatar that can show up to 4 users in its image. And we were kind of worried how we're going to combine that together in Compose. Well, it turned out to be very simple, actually, by just using a few weights parameters and organizing things in a couple of rows or a couple of columns, which is really intuitive and very easy. So we kind of got over that problem in an intuitive Compose way. The next very big thing about our SDK is the message list optimization. So we had to write a ton of codes, a ton of diff-util code for the XML toolkit, just to make sure that we have optimistic updates, which are very fast and real time, so that the user doesn't see the change or there's no jumping around in the UI. With Compose, we didn't actually have to think about it too much because internally it has all of these optimizations on the go. We just applied a few optimizations, such as adding keys to our items, to make sure that everything updates correctly, which is really, really cool. And finally, we had some thoughts about deep customization and how we're going to apply things like attachments or custom attachment factories, colors, and typography to all of our components in one go. And we actually decided to build our own theme, which I'll talk about in a moment as well. And that solved our problem in a much easier and much more straightforward way than we could build it in XML or regular Android View toolkit. And finally, one of the things that I want to kind of go over before I pass on to Márton is component readability and how you can build readable and very intuitive components in your UI. So one of the things that a lot of UI frameworks suffer from is having deep component nesting, which means you have a parent that has a child or a few children who all have another child and so on and so forth, which kind of turns into this trap of component hell, similar to what a callback hell looks like. And because we wanted to avoid this issue, we suggest building something like a more flat structure. So if it's possible for your higher level components to build everything in a flat structure, as well as using some logically decoupled components, it's going to make your life easier when you're looking through these components, when you're trying to build even more custom UI or you're trying to change something. So let's see how it looks like. So in our messages screen example, we have a box as a root level component so that we can show elements that overlay each other. Within it, we have a scaffold that combines a few components such as the top bar, the bottom bar, and the content as the message list. Underneath all that, we have few different overlays that we can show, such as the selected message overlay, if we have selected a message, attachments, if we are showing attachments, the attachment speaker, and a dialog if you're trying to delete a message. And as you can notice, all of this is within the same level. It's not using any kind of nesting except for the box itself. And I guess the scaffold that you can inline as the content parameter. And all of this looks very native, very intuitive, because everything shows correctly. Everything shows as an overlay of the message list, which is what we're looking for, right? Now, another example of how you might go about this is if you had a box which had possibly a drawer, and the drawer content might have some extra animations applied to its content, which might be the attachment speaker. Then within the actual drawer, the content that's shown all the time, you have the scaffold, which has its own internal components that you can also customize or override and have nested components again. This is a bit more complex and a bit more convoluted, so it's hard to reason about this code, but it's still trying to achieve the same thing. Although you can move the drawer to the scaffold, you still have to embed some content within that drawer. So if it's possible for you to build something outside and have it on the same level, it's going to be much easier to understand and much easier to change in the future. So with that, I'll pass it over to Márton so he can talk about our customization options.
All right, thank you. So getting back to how you can customize our SDK, we have this customization approach, this customization mindset that, as Filip shown you earlier, we want to give you really, really quick to integrate out-of-the-box solutions. Dropping in something like the channel list or the message list, which are entire screens at a time, takes about like 3 or 4 lines of Compose code. If you just want the basic, fastest, and most simple integration of it. But we also want to allow a lot of customization on top of this. So here are some things that we're doing and what we're also suggesting for you to do if you build APIs and components in Compose that others are going to consume. So first of all, against hard-coding modifiers, it's a really, really important thing to provide modifiers on components that you expose to others so that they can control how those components are positioned and style them on an individual level. This is something that's mentioned in Google's Jetpack Compose API guidelines as well, which is a very long and complex, but also very valuable document. And you should definitely read it if you're, again, building Compose APIs that others are going to be using. Then you should think about exposing content parameters where it's appropriate. So if you have a large complex component and your clients might want to customize just individual small parts of that large component, then slot APIs can be super useful. You can define parameters which are composable lambdas in your function, and you can let your clients override just those small bits of UI within the larger component. Then think about theming as well. Modifiers and direct parameters on your components are great for local customization of just that one component. But if someone wants to customize all of your components at the same time, such as for us with our Chat SDK, it would be really tedious if they had to pass in, for example, parameters to recolor things into each one of our individual components when they're using like maybe a dozen of them in their application. So think about having some overall theming system, and you can either use material theme here, which is something that's kind of in Compose out of the box, or you can build your own, which is the direction that we went in, and we're going to show you that in just a second. Finally, it's a great idea to provide customization for state. So letting your customers provide their own input state to the components, providing stateless components, if that's possible, so that they can easily integrate in like an idiomatic Compose way where you're supposed to be able to just pass in parameters to each component and have that affect everything that it renders. And in a similar vein, expose action handlers so that clients have a chance to react to whatever's happening inside your component. I'm going to show you an example of the different parameters we offer on a component here. by showing you how our message composer works, which is the view on the bottom of the messaging screen you've seen before that allows you to create a new message. There are three main categories of parameters on this component, which are state, action handler, and finally UI customization and slot APIs. And we're going to look at each of these in turn. So first of all, there's state customization. As you've seen already, we have these bound components that just integrate with view models, and they grab data from our APIs and also send data to our APIs as needed. So you can use these bound components, which will just grab their state from a view model. But we also provide variants of pretty much all of our components that take simple parameters. For example, you can drive the message composer by just providing the current input value as a string, providing the list of attachments, which would be the selected attachments that are going to be sent when you actually send the message, and the active action, which is things like, are we currently composing a reply, or are we editing an existing message because we show some special UI for that. So with these, you can externally drive the message composer and either integrate with our view model, which makes it really simple, or if you want to go custom, you can do that as well. Then we have all of these action handlers. Again, you can hook into these if you want custom behavior while the user is creating their message. For example, you can set your own handler for on-value change, which lets you react to the user putting in new characters into the input, or to the on-send message function, which lets you react to whenever the send button is pressed. And let's take a look at an example of doing that. So here's a call to this message composer function. And as you can see, we're providing a view model, and we're also providing a custom on-send message handler. And we're actually ultimately doing the same thing in this handler that's being done by default. All of these handlers are routed into the view model wherever we can. So for example, the send message handler by default just calls view model send message, which invokes the API and sends that message to stream. But you can hook into this, and you can still call the view model function at the end of your own handler, but you have this chance to intercept the message before it's actually sent down into the data layer. So you can use this handler to do things like add extra data to the message, to put in custom information there that relates to the current state of your application, whatever your domain is. Or as you can see here in this like very simple example, you could do things like modify the actual text of the message before it's sent. So this is a really nice like pre-send hook for sending a message. Then we also have slot APIs, which is the UI customization part of the parameter list of message composer. Here's the composer on the right-hand side, and here are three of the slots that we offer. The first is the integrations slot. This is the area to the left of the input field. And by default, we have a button here that opens the attachment speaker that lets you browse images and files that you want to add to the message. But there are a lot of customization requests from our customers to put just completely arbitrary buttons here. So for example, a button to record voice messages, a button to send location, a button to open a sticker sheet where you can browse stickers and then send them, and so on. And the way that we can provide full flexibility here is to just take a composable function and render the contents of that composable to the left of the input field. As you can see, we have a default implementation for this, which contains this button, but you can put pretty much anything, any arbitrary UI in there. Similarly, we offer customization for the hint, the label for the that's displayed inside the input. This by default is just a simple text that says send a message in it. But again, we offer full customization by giving you a composable function parameter. If we give you a string, you could change just the text in there. But this way, if you have your own text component with some special styling, or you want to put an icon and text in there, you can freely do it because we're just taking a composable that's going to be used there. And of course, you can also replace the entire message input as well. We're actually using one of our other components here, which is called message input by default. So if you want to provide this value on your own, you could reuse our message input and customize it, or you can just implement everything from scratch if you really want to. Finally, let's talk about our theming. So we have this chat theme composable, which we use for all of our global theming needs in the SDK. And this is a very similar solution to how material theme and basic compose application themes work. So we take a content parameter here, which again is a composable lambda as the last parameter. And we provide a bunch of different values to it as composition locals. We provide things like colors, typography, shapes, and so on. And let's take a look at just one specific example. We provide colors, which is an object of the type stream colors to all of this content. And we actually use two different sets of colors by default. We provide you a default dark and a default light color arrangement. And all of our components require you to use them inside the chat theme because they're going to be reaching out to these composition local values and grabbing the colors that they should be displaying. And this is what the stream colors class looks like. It's just a very simple data class. You can also see the two palettes here from our UI kits design. And you can see that these colors just map to color property inside the data class. And just like we've implemented the light and dark color palettes, you can very easily create your own instance of this class, put in your own colors that you want the SDK to use. For example, if you want to brand the chat experience a bit, you can add your own brand's color to the primary accent color, and that will display in all of the components that are wrapped inside chat theme. And the same goes for typography and other theming options. All right, to wrap up, we want to point you to some useful resources. First of all, we would love for you to check out our SDK on GitHub. We somehow haven't mentioned this yet, but our SDK is open source. Our entire Android SDK from the network client all the way to the Compose UI. Give us a star if you like the SDK. And for Compose, we're actually doing even more open source than before. We're running the entire project in an open source way, so everything that we're working on is visible in the GitHub project and in our GitHub issues. So yeah, you can browse that, and perhaps if you want to work on some Compose code, you can also contribute to like some simple issues there. Then we, of course, have a tutorial for our Compose Chat SDK, which shows you how to get started with the simplest integration at first, and then proceed to more advanced customization, starting from just a blank Compose project. And we have full documentation for our Compose components, which you can use to find out how to customize them and how to integrate them into your application. Our Compose SDK is still in a beta. So if you reach out to us either on GitHub in issues or discussions, or on Twitter at getstream_io, we are super happy to hear any and all feedback about it. And we have some resources here for Compose in general. Again, the API guidelines from Google, super important document, really good if you're designing APIs for others that are in Compose. We have the link to the Compose pathway here from Google, which is a series of code labs and articles that teach you the basics of Compose. And finally, we have a link to a GDG YouTube channel here, which has some great talks from Filip about beginner and advanced Compose. And that's a wrap. Thank you so much for attending this talk today and following along with us. And we would love to answer some questions if you have any. I think I've seen a few things in the chat.
There are 3 questions in the chat. Yes, 3 questions in the chat. So the first question, how did you handle the testing of Compose functions?
Yeah, so I can kind of go about that. So I think it's kind of revolving to the other question as well, is passing parameters. So the thing about our components is that they do use view models, the bound components, but all bound components internally use stateless ones. So in that sense, you don't really have to test these more, let's say, complex components such as the view model or the bound components, because you can just test the stateless version and the output should be the same always. Then on top of that, or under that, I guess, you can test the view model itself. And in that sense, you have a clear integration of the business logic itself, as well as the UI part of components. And in that sense, in terms of passing parameters, since all of our, or most of our components are stateless internally, you can always pass in the state that is pure, that doesn't rely on anything like an Android lifecycle. and you'll always get the result for your previews. So you might have different types of previews for, let's say, the message list, which has a stateless version, which shows the empty view, the loading view, or messages. And you can just pass 3 different types of messages states that represent these views. In that sense, you will get preview for all 3 options. And it's very easy because you just create one data class or a few different objects. So hopefully that answers your question. Were you going to add something, Márton?
That's the core part of the solution for that. So all of the stateless components take just very simple models like strings or regular data classes with just data in them. So you don't need to worry about instantiating something complex like a view model. I don't know if we have any previews in the SDK at the moment, like actual Compose previews. That's something that we're going to be expanding on in the future, because obviously we have a lot of work to do in the SDK in general, but it's absolutely possible to do because you can just provide that raw data easily.
Yes, so we're kind of lacking on that side because of our capacity, as it's currently just me, but hopefully we'll get some extra help in the future to go through that. I'm not sure if we have time for the next question, but it should be pretty simple. So in terms of organizing composables and the file structure, again, we're trying to approach with this, such as like a clean approach or just a very basic, very logical decoupling. So we have separate state, view model, and then UI packages for our SDK. Within UI, we have separate packages for each feature or each smaller part of our SDK. So for example, we have the messages package that has all the UI components for the messages screen. At the top level, in that package, we have the messages screen itself, which is very easy to use, and it gives us like an inside view within the entire feature. And then for each smaller feature within messages, we have a separate package that holds files for that. So for example, messages has the header package, it has the list package or list items, and then finally the composer. And within that, you can organize your files based on how complex or how decoupled your features are. So for example, for the message list, we have one file that has 3 functions in it or 3 components. The first is always at the very top. We have the bound component because we want to have a look at that. That's what our users will generally use most of the time. Underneath that, we have the stateless version. And finally, because we are showing the list within both the bound and stateless versions, we have the messages component at the end. However, the item itself for the messages component is decoupled to a separate file because it internally has a bunch of smaller components, such as the avatar, such as different timestamps, different footers, and different types of content based on the message type. So hopefully that kind of gives you an idea of how it works. So it's generally a top-down approach. You can take a look at the entire screen. Once you see the screen, you can take a look at every single feature specifically. And then if any of the features uses a more complex item component, if it's like a lazy thing, like a lazy list or something, then those items are also decoupled in their own file with all the components that they might use. And one small note is that sometimes we have components which are common or commonly used, which are very, very simple, very stateless. So for example, we have a timestamp component that is in its own or in a common package that is just generally used. It's not really tied to messages or channels specifically. It can be used across the entire app. So hopefully that answers your question.
I have something very important to add on to that. Please go to our GitHub repository, star it, clone it, and then check out the structure yourself, because that's why we have that there.
And as Márton mentioned before, we are super happy to take in any type of feedback, or if you're interested in contributing to the SDK, you can see a list of our open issues tagged with the Compose label, as well as a project that we're running through each sprint. So you can take a look at that and you can see what we're working on currently, as well as what we're kind of planning for future milestones or what we worked on previously. So if you have any kinds of suggestions or things we might want to improve on, just feel free to let us know. We'll be happy to take in that feedback.
Awesome. Thank you.